All right, so this is also from worksheet 3.6x tension practice. This is number 14, where we do have friction. And as it says at the beginning, when we do have friction, mu is in this case 0.2. And also a reminder that the mass m is 1 kilogram. And so we have three objects here connected by strings, frictionless pulleys, massless strings. And I'm going to call this object 1, this object 2, and this object 3. And so first step, always with drawing these, is to draw a free body diagram for each. And so for the first one, for object 1, the free body diagram for that mass is, well, you have a tension going up, and I'm going to call that tension 1. And you have a mass, so you have force of gravity of object 1, which is equal to mass, which is 2m times g. For object 2, we have the following forces. We have normal force acting up. We have force of gravity acting down. Force of gravity on object 2. And this is going to equal m, which is mass, which is 4m times g. And we also have tension 1 acting in that direction. And we have what I'll call tension 2 acting in that direction. And we also have friction present in this case. So we have, since the system is going to move to the right, we have a heavier mass over here, 3m, versus the 2m over here. So I know that as this system moves to the right, force of kinetic friction is going to act to the left. So we have those 5 forces acting on object 2. And for object 3, we have the following 2 forces. We have the force of gravity for object 3, which equals mass, which is 3m times g. And we also have tension 2 acting up. So once again, these two tensions are the Newton's third law of force pairs with one another, and these two tensions are also Newton's third law of force pairs. So we're going to, again, look at this in terms of a one-dimensional, sort of a modified one-dimensional sort of problem. This whole system can either move to this way to the right, or the other way to the left. So let's call this positive and this sense negative. And if we do that for object 1, I'm going to say that the sum of the forces in the direction parallel to motion equals the mass of object 1. The mass of object 1 is 2m times its acceleration. Similarly, for object 2, the sum of the forces parallel to the direction of motion, which is to the left and right for object 2, equals the mass of object 2, which is 4m times its acceleration. And for object 3, the sum of the forces acting parallel to the direction of motion, which is up and down for object 3, is equal to the mass of object 3, which is 3m, times the acceleration of object 3. Now again, since all of these objects are connected by a rope, the acceleration values are all equivalent. And if we start looking at specifically the forces that are acting parallel to the direction of motion. For object 1, if you look at our free body diagram, you have tension 1 acting in the positive direction, and you have the force of gravity acting in the negative direction, and that equals 2m times acceleration. For object 2, in the direction of motion, you have 3 forces. In the positive direction, you have T2. In the negative direction, you have T1 and the force of kinetic friction. And those all combine together to give us mass times acceleration. And for object 3, we have 2 forces in the direction of motion. We have, in the positive direction, force of gravity on object 3. In the negative direction, we have tension 2 equals mass times acceleration. So we have several variables here, and so we need to play some of our algebraic games once again. What do we know and what don't we know? So in the first problem here, and for the first object, T1 is something we do not know. So that's one of the things we're solving for. We do know the force of gravity on object 1. Since m, so the force of gravity on object 1, that's this, 2 times 1 times 9.8. That gives us 19.6 newtons. 19.6 newtons equals what the force of gravity acting on object 1 is. So I can plug that in here. And I'm going to keep units out just to keep it sort of cleaned up here a little bit. I have to be very careful though when I do that. So 19.6 newtons equals 2 times m, well, mass. M is just 1 kilogram. So 2 times 1 kilogram is 2 kilograms times A. A is one of the things I'm solving for. Moving on to the next item. T2 is one of the things I'm solving for. T1 is one of the things I'm solving for. Force of kinetic friction, do I know that? Well, actually I do. If I do a little side work for this, let's see, I'll do it right down. Let's see, where can I squeeze it in here? So the force of kinetic friction, I'll put it up here in this space in the box. Force of kinetic friction equals mu sub k times the normal force. Well, mu sub k equals 0.2. The normal force, if you take a look at the in the direction perpendicular to motion, so the sum of the forces perpendicular to motion in the y direction, in other words, has to be 0 because this thing is not going to accelerate up or down. So you have normal up subtract force of gravity on object 2 down equals 0. So normal force equals the force of gravity on object 2. Force of gravity on object 2 equals 4 times 1 times 9.8. So we actually know what that normal force is. 4 times 1 times 9.8 will give us 39.2 newtons. And so if I plug that in for the normal force over here, 39.2 newtons, we can come up with a force of kinetic friction to equal 7.84 newtons. And so this is an actual number, minus 7.84 newtons equals 4 times m. Well, m is just 1 kilogram, so 4 kilograms times A. A is one of the things we're solving for. And for object 3, I do know the force of gravity on object 3. It's 3 times 1 times 9.8, which equals 29.4 newtons. And so I can, that's acting in the positive direction here, so 29.4 newtons. Subtract T2, that's one of the things I'm solving for, T2 is, equals 3 times 1 kilogram, so 3 kilograms times A. So again, I have a system of equations. I have 3 unknowns that we're solving for, but then I also have 3 equations. So with the 3 equations and 3 unknowns, my unknowns are acceleration, T2, which appears a couple times here, T1, which appears a couple times here, and so I can solve for this. When I solve for this system of equations, I will get for my acceleration to equal 0.218 meters per second squared. And that's the acceleration of this whole thing. So this whole thing is going to be accelerating to the right at a rate of 0.218 meters per second squared. Once I know that, I can solve for T1 and T2. T1 equals then 20 newtons, and tension 2 equals 28.7 newtons. And that is everything.